All right, so when we're looking at writing complete electron configurations using the entire periodic table, there's a pretty straightforward trend that we use to actually figure this out. Think of an electronic configuration as a pathway on how to get to the specific element of interest. Keep in mind that we have specific orbitals that move through in each case. So our orbital over here, that's our s orbital. We've got our p orbital over here, with the exception of helium, of course. Remember that helium is in the s orbital. We have d, and then we have f down here. So keeping all of those things in mind, we're going to kind of work through a couple of simple ones to kind of get a handle on how these things work. So for instance, if we're looking to get to sulfur, we have to work through kind of essentially how do we get there? What's our map? What's our plan? So we always fill up our periodic table going left to right. So in order to get all the way to sulfur, we have to pass through all of these locations. Eventually we'll end up where we need to, but somehow we need to kind of give directions on how that happens. So the first one we move through is our s orbital. So you notice that, again, we have our s orbital, and there are two things there. The other thing to keep in mind is each of these have a period number that goes along with them. So in this case, it's our first row. We know it's our s orbital, and we have two things there. So we would label that as 1s2. That's our first direction to know that we've filled up that location. On to the next one. So now you notice we also pass through this area right here. So this is our second row, also our s orbital, and we've used both of those things. So we've got our 2s and then 2. We keep going to the right, and we notice we pass through this section over here. So we have to indicate those directions in our pathway or our map. So you notice again, it's our second row. It's now our p orbital, and we're going through 1, 2, 3, 4, 5, 6 things. So that's 2, p, and then 6. We keep going, and we notice we're down to this one now. We have to pass through these two sections. So you notice our third row. We use both of our things, and it's in the s orbital. So we indicate that by saying 3, s, and then 2. Continuing on, we're now into our p orbital, because remember, sulfur is our goal over here. So it's our third row. It's our p orbital over here, and we're 1, 2, 3, 4 things into it. So it's our third row, p orbital, and the fourth thing in there. So that's our complete electron configuration for sulfur. Working through those same kind of ideas, let's take care of something that's a little bit more obnoxious, it's a little bit larger of an atom. So for instance, let's take into account something like germanium, number 32 here. So 32 is much further along in the periodic table, and you notice that we have to pass through the d orbital in order to get there. So following the same piece of information we used last time, we again are filling left to right, and our goal is to get to germanium. So we've made it to our section there. That's our goal. So again, we're going to work row by row, piece by piece. We're going to map out how we get there. So you notice again, it's our first row. There's two things in here, and it's both our s orbital. So it's 1, s, 2. Continuing on, notice again we're going left to right. Now we're down to this one. It's our second row, s orbital, and we have two things located in that one. So 2, s, 2. Continuing on over here. It's still our second row. Now we're in the p orbital, and we pass through 1, 2, 3, 4, 5, 6 elements. So 2, p, and we go through all 6 of those. Continuing on in our progression, we're now in our third row. It's our s orbital now, and there are 1, 2 things there. Going all the way over. Still our third row. We're now in our p orbital, and you notice we're going through 1, 2, 3, 4, 5, 6 things. Down onto the next row. We're now in our fourth row. It's our s orbital, and there are 1, 2 things there. So 4, s, 2. Here's where things get a little tricky. The d orbital is a little strange. So the d orbital's row notation, so that's this number 4 out here, is actually one step lower than what you think it should be. So it's our d orbital. It's in our fourth row, but remember this is going to be one row lower than what we want it to be. So it's actually 3. It's our d orbital, and we pass through 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 things. It's one row lower by convention. So scientists over a long course of time have kind of picked out where all of these energy levels go, and they decided that d was going to be one energy level lower than what we thought it should be or what it would be. Continuing on our progression, however, we're back into our p orbital over here. You notice we're in the fourth row again. So fourth row, we're in the p orbital, and we're 1, 2 things in. So 4p2. So there's how we would get to germanium's complete electron configuration. Remember that the d orbital is 1 row lower than what we think it should be, and the f orbital down here is actually 2 rows lower than what it should be, keeping in mind that this f orbital actually goes here. So after we hit lanthanum here, we have to jump down here and go into our f orbital. So we go right from that 6s2, boom, right down here to our 4f. Keep in mind that this is 2 rows lower than what you think it should be. Now we can continue following this left to right pattern as we kind of go through the periodic table, and we're trying to find which elements we're going for. But if you're like me, you always look for kind of a way to speed up the process and a way to make things a little bit easier to work with. So if we're going to pick something, let's pick something like, I don't know, let's go through selenium here, so number 34. For me, if I'm going to speed up this process, I always jump to the thing I know last. So in this one, it's our 1, 2, 3, 4th row. 4th row, we're in our p orbital, and it's 1, 2, 3, 4. So it's going to be 4p4. So I know that's where I have to end. So knowing that I have to finish at this 4th p orbital, and I have to put 4 electrons in there, 1, 2, 3, 4, everything in order to get here has to be filled up first. So we have to fill in all of these things down here. So I know that there has to be 2 electrons here, 2 here. Each blank essentially gets 2 electrons. So I can continue this process all the way up if I want to fill up my diagram, or I can jump just straight to filling all these things up. So I know that for my electron configuration, it's going to be 1s2, so 1s holds 2 electrons, 2s2, going up 2p6, 3s2, 3p6, 4s2, 3d10, and then I know I have to end at 4p4. It speeds up the process a little bit so we don't have to count every single time. I can jump right to the end and just know I have to fill in everything prior to that before I get there. It's kind of a way to speed up the process if we're looking to do a complete electron configuration based on a specific element we have. Because keep in mind that selenium was in the 4th row, our p orbital, and our 4th column in that row. So we jump right there to the end and we fill up everything that leads into it. Keeping in mind each blank gets 2 arrows or 2 electrons as we fill up our orbitals.